In this lesson, we're going to learn how to simplify exponents that have the same base. We will learn how to apply the product rule and the quotient rule. So first of all, we have the product rule. So we have gone over the zero rule and the negative exponent rule. So now we're going to have the product rule. So the product rule allows us to simplify when we are multiplying like powers. So when the bases are the same and we're multiplying, the rule says that we can add the exponents to create one expression. But let's take a look at why that is. Why can we add the exponents? So we have a squared times a to the third. We're going to expand a squared into a times a, and then it's multiplied by a times a times a. So really, we have 5 a's that are being multiplied. So you can see that 2 plus 3 gives us the 5. Let's take a look at one more example to expand. We have 2 squared times 2 to the fourth. 2 squared is 2 times 2, and then times 4 more 2's being multiplied, which is a total of 6. Okay, now let's look at some examples, and let's just apply the rule and not expand. We have like powers, like bases, so we have c to the 8th, 5 plus 3. Here, our bases are the same, so we're going to have m. 2 plus negative 4 is negative 2. But remember, we can't leave a negative exponent, so we're going to reciprocate the factor. Our third example, we have z to the negative 3 times z to the negative 1. This gives us z to the negative 4. Again, we're going to reciprocate to get rid of the negative on the exponent. Our next one, we have some coefficients. We're just going to multiply like we have always done. 2 times 3, 6. Now we have a to the third times a to the fifth. So that's going to be a to the 8th. 4 times 2 is 8. And then we have b to the negative 1 times b to the positive 1. I always like to write in my understood ones because every factor has an exponent. So when we add negative 1 plus 1, we get 0. Let's go ahead and simplify b to the 0. We know b to the 0 is 1, and 1 times 8 is 8. Our last example here, we're going to multiply negative 3 times 2. So this is just a negative on that base. So we have negative 6. And now we're going to apply the product rule. 2 plus negative 5 is negative 3. Now we need to simplify this negative exponent. So this is negative 6 to the positive 1, so it stays where it is. And then we're going to reciprocate k and make it have a positive 3. Okay, pause the video and you try these. Okay, number 1, we have like bases, so we're going to have 9 squared. If we went ahead and evaluate 81, that's fine. Number 2, we have a squared times a to the negative 3. That gives us a to the negative 1. Then we have b to the negative 1 and b to the positive 1. We have b to the 0. We're going to reciprocate the a and bring it to the denominator. B to the 0 is 1, and we need that 1 for our numerator. Number 3, 2 times 3 is 6. And then we have x to the negative 1. Remember, this negative 1 is only attached to the x. So we have 6 over x to the positive 1. And the last one, 5 times 3 is 15. We have a base of g and a base of h. G to the 1 times g to the negative 4 is g to the negative 3. H to the negative 2 times h to the positive 1 is negative 1. Both the g and the h need to be reciprocated to the denominator and having all positive exponents. The 15 has the understood positive 1. It remains where it is. Now let's talk about the quotient rule. Since multiplication and division are inverses, so are the product and quotient rule. So this time, instead of adding exponents, you're going to subtract. So here's our fourth rule. Subtract exponents. So let's show why that is. Let's expand x to the fourth, and we're dividing it by x to the third. Now, when you have a number divided by itself, you know it is 1, or we cancel it. So here, x to the fourth divided by x to the third is simply x to the 1. 4 minus 3 is that understood 1. Next, we have 2 to the fifth divided by 2 squared. We're going to cancel, and we're left with 2 to the third. 5 minus 2 gives me the power of 3. Now, let's do a few together. We're just simply going to apply the rule. We're not going to expand. So I have 7 minus 3 gives me an exponent of 4. And you'll see why I'm writing these out, especially when we start having negatives involved. With subtraction, I always write out my work. I have negative 4 minus 2. That gives me negative 6. We're going to reciprocate. Number 3. Now here we have 12 over 3. Our coefficients. We're just dividing 12 divided by 3. That gives us 4. Now we're going to start with our variable in the numerator, and we'll tweak it if we need. So we have 3 minus 5. That gives us negative 2 on the a. So we're going to reciprocate a to the negative 2, and we'll get 4 over a squared. Remember, 4 has an understood positive 1, so it stays in the numerator. Now, let's take a look at 18 over 24. It does not divide into a whole number, but we are just simplifying just as though it were this. And by the way, you can always break these factors apart if that helps you see it better. So 18 over 24, they both can be divided by a factor of 6. So we get 3 over 4. Now let's evaluate the variable. I'm just going to go ahead and write my factor or my base W in the numerator. And we're going to say 5 minus negative 3. So many times folks want to say that this is going to give us a power of 2 or an exponent of 2. No. 5 minus negative 3 gives us an exponent of 8. Now pause the video. You try these. When we come back, we will go over those together. Okay, so here we have h, and we have negative 2 minus 6. That gives us negative 8. We will reciprocate and have 1 over h to the 8th. Number 2, let's look at, we have the a's, so I'm going to put my positive 1 there. So I have a 1 minus negative 3 gives us positive 4. Then we have a base of b. 5 minus negative 1. We have a power of 6, and everybody's positive. Number 3, we have 8 divided by 2, and then we have g squared divided by g to the negative 4th, and k to the negative 1 divided by k to the positive 1. So we're going to evaluate each of these factors. We get 8 divided by 2 is 4. Then we have a g, and it's 2 minus negative 4 gives me an exponent of 6. Then we have a k. We have negative 1 minus 1 gives me negative 2. So 4 and g both have positive exponents, but we need to reciprocate the factor of k squared. Now let's look at our last one here. Again, it's nice to break it apart, especially when you have multiple factors. So 18 and 12 has the greatest common factor is 6, so that gives me 3 over 2. We're going to start in the numerator with both our y and our z, and then we will tweak at the end if needed. So we have 2 minus negative 3. Oops, it's positive. 2 minus negative 3. 2 minus negative 3, making sure. So that gives me positive 5. Then we have 5 minus 4 gives me 1. So most of the time I do not write the understood 1, and you want to write as little as needed. And there's our final answer.